We can also write the identity and inverse properties in terms of equivalent expressions. First, the identity properties. The additive identity is 0 because for any real number a, the expressions a plus 0, 0 plus a, and a are all equivalent. Similarly, the multiplicative identity is 1 because for any real number a, 1 times a equals a times 1 equals a. We can also state the inverse property. The additive inverse property says any real number a has an additive inverse, the opposite of a, such that a plus the opposite of a equals the opposite of a plus a equals 0. The multiplicative inverse property, note the complication here, says any non-zero real number a has a multiplicative inverse, the reciprocal of a, such that a times the reciprocal of a equals the reciprocal of a times a equals 1. Also note, if a is a fraction p over q, we write q over p instead of 1 over p over q. Alright, how does this let us build new equivalent expressions? Well, in writing equivalent expressions, we are allowed to write in or delete adding 0 or multiplying 1 as the fancy strikes us. We can replace a plus negative a by 0, or we can replace 0 by a plus negative a. We can replace a times 1 over a by 1, or we can replace 1 by a times 1 over a. Here's an example of a place where that might come in handy. Let's say I want to figure out what I need to multiply by 2/3 in order to get 5/6. Well, one way I could figure that out is to start with 5/6 and to write that as 5/6 times 1. Right, I can do that. It's free to write in times 1. Now my goal is to get that in the form something times 2/3. Well, I know that 1 is 3/2 times 2/3. Now I can apply the associative property to say 5/6 times 3/2 times 2/3. And that's going to be equivalent to, let's see, 5/6 times 3/2. I think I'm going to get 5/4. You're welcome to work that out either on a calculator or by hand off to the side. And so we see 5/4 times 2/3 equals 5/6. Oh, hey, you know what I just noticed? This line of reasoning shows us why division ought to be multiplication by the reciprocal. That is, why division ought to be multiplication by the multiplicative inverse. Why? Well, we want to find out what we need to multiply by 2/3 in order to get 5/6. We know that we can multiply 5/6 times 1 and get 5/6. So that's multiplying 5/6 times 3/2 times 2/3. The same line of reasoning works for subtraction. I want to know, what do I add to 7 in order to get 5? So I'm going to start out with 5, and my goal is to get something plus 7. I can write 5 as 5 plus 0. And 0 I want to write as something plus 7. 0 is negative 7 plus 7. Now, the associative property says that's 5 plus negative 7 plus 7 5 plus negative 7 is negative 2. What do I have to add to 7 to get 5? I have to add negative 2. There are other ways that this move is going to be useful to us in the future, but this is a very simple example of why we might want to make a move of this kind.